Hi all, welcome back. And in this video, we are going to learn about relations. Not the boring relationships, but relations in discrete mathematics. So, in discrete mathematics, we are going to learn about this relations, and we would be learning relations on set, not human relations, of course. So, relations on set. Right, I hope the topic is clearer. So in this video, first of all, we are going to see what does this relation means. So let's say we have two entities A and B, and if A is somehow related to B and B is somehow related to A, we categorize them and we say it as an ordered pair. Okay, or in other words, we can say that A is related to B and B is related to A. So this is an ordered pair, right? And definitely, if we have a set A and we have a set B, so if we cross multiply these two, so we get something in the form of ordered pair A and B, where A belongs to A, set A, and B belongs to set B. Now, why it is called the ordered pair? So, if we write two elements like and A and B are somehow related to each other, so in this way, if we A appears prior to B, so it follows a certain kind of order. That is why it is known as the ordered pair. Okay, so A and B in this way is not equal to B and A. That is why ordered pair is a specific term being used for A and B. Now, let's say we have one set called A, and in A we have the components like 1, 2, and 3. And similarly, we have set B, and it has certain elements like 2, 3, 4, and 5. Now, let's say we are doing a cross product of A and B. So, what are the elements we are going to form? So, every element of A will cross multiply with every element of B. So, like this, we are getting 1, 2, 1, 3, 1, 4, 1, 5, then 2, 2, 2, 3, 2, 4, 2, 5, then 3, 2, 3, 3, 3, 4, and 3, 5. So in this way, we are getting one or set called A cross B, which consists some ordered pairs like 1, 2, 1, 3, 1, 4, 1, 5, and so on, which is obtained by multiplying every element of A set A with every element of set B. Now this is basically ordered pair. Now let's say if we are defining a relation on A cross B like equal to. So we are saying that pull out all those ordered pair from A into B, which in which uh, the first element is equal to the second element. So this is a equal to is a relationship operator. Like in human relation also, we are saying that there are certain people, certain person in a room, and we say that pull out those people in pair who are sibling to each other. So we are defining a relationships, right? So here also I'm defining a relationship called equal to, in which I'm defining this equal to operation on set A into B, where I'm saying that the first element has to be equal to the second element. So if we define equal to, so we are obtaining some ordered pair in which the first element is equal to the second element, like this. And do we have more? I don't think we have more. So it is 2 2 and 3 3. So this ordered pair, this is all called relation in which the first element of this ordered pair is equal to the second element of the ordered pair. Similarly, if we say that let's define a relation greater than on the set A cross B, where second element is greater than the first element. So this will fall in this. Okay, so this will fall in this, 1 4 will fall in this, then 1 5 will fall in this, then of course 2 3 will fall in this, 2 4 falls, 2 5 falls, then 3 4 falls, and 3 5 falls, right? So the ordered pair which follow this relation is 1 2, 1 3, 1 4, then 1 5, then 2 3. Okay, then of course 2 4, then it's 2 5. Okay, then 3 4 and 3 5. So 3 4 and 3 5. So all these pairs follow this relation, so such that first element is second element is greater than first element, or first element is less than the second element. So altogether how many components are there? 4 5 6 7 8 9. So altogether there are 9 pairs, order pairs, right? Similarly, if we say that we need to define a relationship less than equal to, such that so it is greater than equal to in terms of first context, so first element is greater than the second element, so that also we can check from here. So first element is greater than the second element, so I think this is one, 3 2, and I don't think there is another element like that. No. So our element includes 3 2. Okay, so only one element will be there, 3 2, such that first element is greater than the second element. So all these are the type of relations which is defined on the cross product of A into B. And if we say we define a relation called brother of, so first element is brother of second element, so is that relation possible? No, so this set will be empty. So there is no relation such that X is a brother of Y in the ordered pair XY, such that X belongs to A and Y belongs to B. Similarly, if we are defining a relation like X plus Y is greater than 9. Okay, so we need to define any two pairs like 1, 2, like this, such that 1 plus 2 is greater than 9. So is it possible on A cross B? Sorry, A cross B. So on this set, is it possible to get this kind of relation such that X plus Y is greater than 9? I don't think, because the largest we can get is 3 plus 5, that is 8, and that is not greater than 9. So this part will remain empty. So we have an empty set for this. Okay, so in this way, we can define multiple relations on a particular set based on certain conditions, right? So this is what we are going to discuss in this. So here comes the definition from that. Excuse. So here comes the definition for that, that a relation R from set A to set B, or from A to B, is a subset of A cross B, right? Or that is, we can say that R relation, set relation R is a subset of A cross B. So we have seen all those relations, and those relations are a subset of A cross B, right? There is one more term called inverse relation. So what is this inverse relation? Inverse relation. So it is nothing but, if R is a subset of A cross B, then R inverse, that is the inverse of relation R, is defined as a subset of B cross A, and it is defined as R inverse is equal to AB, such that BA belongs to R. So if BA belongs to R, then R inverse is AB, right? So it is just we are reversing the order of the order set. Okay. So if we see that in relation R, and if we compare R inverse, so if we define equal to as an operation on A cross B, so in R inverse, if you see, if we reverse this order, it is also going to remain the same, right? So equal to is same for R as well as R inverse. But if we define greater than, so if we define that second element has to be greater than this, so if we reverse this order, so what does happens? 2 1, 3 1, 4 1, 5 1, like this it appears, right? So what happens, that we get order in such a way that it becomes 2 1, 3 1, 4 1, right? And 5 1, 3 2, 4 2, 5 2, 4 3, and 5 3, like this way. So this R inverse becomes, so this sign gets changed for this, right? If we define less than equal to, it becomes this, right? If we apply divide, okay, then it becomes multiple of. And if we define is a subset of, then it gets opposite way, like this one. So we'll see about all these things. So this was just the basic of what we know as a reverse relation. So we'll see more of the relation topic in the upcoming video. There will be composite relations, there will be a lot of relations we will be talking of, like reflexive, irreflexive, symmetric and asymmetric, like that. So for that, till that, keep watching. Thank you very much.